Which of the following functions has or have a minimum value at -3? Here we have two functions, f of x and g of x, and we don't have domain for both the functions, that is the values of x. Since we don't have domain, we can consider all real values for x in both the functions. Okay, now let me draw a real number line. Here we have negative infinity, on the right side extreme we have positive infinity, in the middle we have 0. We can consider this real number line as a domain for both the functions. That is, we can consider the values on this real number line for x. And we can split up this real number line into three parts. The first part is negative infinity comma 0. The second part is x equals to 0. And the third part is 0 comma positive infinity. Okay, in the first part we have only negative values. Here we have 0. In the third part we have only positive values. And if I want the function f of x to have a minimum value at -3, then this function f of x must have -3 as minimum value in all the three parts of the domain over here. Then only we can conclude that f of x can have this -3 as minimum value. Okay, now let me verify the function f of x with each of the three parts of the domain over here. Let me consider the first part, negative infinity comma 0. Choose a random value in this interval. Let's take a -1 and plug in that value for x over here into the function f of x. Then we get f of -1 equals to -6 times 3 to the power of -1, -3. F of -1 equals to -6, and we can write this 3 to the negative first power as 1 over 3, -3. Okay, 3 goes into 3 one times and 3 goes into 6 two times. We get f of -1 equals to the simplification of this one is -2, and we can write this -3 as it is. Okay, f of -1 equals to -5. This value -5 is less than -3. When I take a random value in the first part of the domain, I am getting a value for f of x which is less than -3. Since f of x is having a value less than this -3, so this function f of x cannot have -3 as a minimum value. So we can reject the first function f of x. Okay, let me do it. Now let's do the same thing for the function g of x. Let's choose a random value in the first part of the domain. That is -1. Let's plug in -1 for x into the function g of x. Then we get g of -1 equals to -3 times 6 to the power of -1. G of -1 equals to -3 times, this can be written as 1 over 6. Here 3 goes into 3 one times, 3 goes into 6 two times. G of -1 equals to -1 over 2. Actually, this value is greater than -3. So when I take a random value in the first part of the domain, I am getting a value for g of x which is greater than -3. So not only for -1, if I take any other value in the first part of the domain, so the value I am getting for g of x will be greater than this -3. So in the first part of the domain, this -3 is the minimum value for the function g of x. And the same thing we have to do for the other parts of the domain. Okay, let me consider the second part of the domain, that is x equals 0. Let's plug in this 0 for x over here. Then we get g of 0 equals to -3 times 6 to the power of 0. -3 times, and the value of 6 to the 0th power is 1. -3 times 1 is -3. In the second part of the domain, we have only one value for x, that is 0. For that value of x, we get the -3 as a value for g of x. Since we get only one value for g of x, that is -3 in the second part of the domain, we cannot consider this one as a minimum value or maximum value. There is only one value for g of x in the second part of the domain. Okay, now let's move to the third part of the domain, that is 0 comma positive infinity. Let's choose a random value in the third part, that is 1. Let me plug in a 1 for x into the function g of x. Then we get g of 1 equals to -3 times 6 to the first power. Okay, -3 times 6 to the first power is just 6. -3 times 6 is -18. This value -18 is less than this -3. So in the third part of the domain, the function g of x is getting a value which is less than -3. Since g of x is getting a value less than -3, we cannot consider this -3 as a minimum value for the function g of x. So we can reject the second function g of x as well. So both the given functions do not have a minimum value at -3. So the correct answer choice for this question is D, neither one nor two.